We've previously discussed the heating curve of water. Now we're going to talk about a phase diagram. And so a phase diagram is similar but different, of course. So it has to do with phase or state. That means solid, liquid, or gas. That's what that means. As a function of both pressure and temperature. So if we're looking at water, now all of these phase diagrams are going to have some pressure value, and then they're going to have a couple of temperature values. So the pressure value is usually going to be the pressure of boiling. So this is going to be like your vaporization pressure. So that's actually going to be your vapor pressure at boiling, at your boiling point. And then here, this is your freezing or melting, freeze, melt, and your boiling point temperature. So let's look at kind of where things are. So again, we tend to think of phase changes occurring at temperatures, which, since we live on the earth, the atmospheric pressure is generally around the same, so there's not much change. However, you can create situations, particularly, if you're going to be going into engineering, this might be something that's very beneficial to you, where you don't want to have to go through a liquid, where you would rather go directly from solid to gas. And so you need to point out like what's happening on each of these. So the solid is generally going to be somewhere to the far left. The gas is going to be somewhere where you start on the far right, and the liquid is somewhere in the middle. So again, depending on the substance, these curves are going to look really different. Now, so this point here is where you go from solid to gas or gas to solid. So generally, they're going to talk about like the heat associated with. So this would be like the delta H of sublimation. So this occurs at low pressure and low temperature. So this goes solid directly to gas. So solid to gas. Here, up here, you go from solid to liquid. Well, we call that melting. So that would be heat of fusion. This would be heat of sublimation. Again, these are temperature dependent and pressure dependent, so depending on where you are. And then this here is liquid to gas, and so that's going to be heat of vaporization. Now, on all of these curves, there's going to be somewhere where all of these lines intersect. That is called the triple point. At the triple point, you have coexisting solid, liquid, and gas. And for water, that is right around, so it's less than atmospheric pressure. This is kind of like a high altitude situation. So it's a little bit lower pressure and a little bit above zero. Again, this is not to scale, so where it actually occurs, I don't know actually, but there is a point, and there's a point on all of these phase diagrams where this is existing. So then you also have the critical point. Now remember, the critical point, that is where the density of the liquid equals the density of the gas. So you can't tell. So note, the line stops here. And so at this high pressure and very high temperature, note, now, mine's in color. Yours will probably be shaded, but there is no line. So the line disappears. So this is where you can't tell if it's a solid or if it's a liquid or if it's a gas. It just kind of looks the same. And that's called the supercritical fluid. So it's both a gas and a liquid at the same time. Isn't that weird? So like, how would you apply this? You would apply this, let me take my black ink pen here. So I have my black ink pen. You might get a question that says at point, you know, it might draw like a point here. And it would say, you know, but it's not going to have these things listed out. You're just going to have a phase diagram. And it would say like what phases are occurring, you know, are present at point A. And you would say, well, that would be a solid and a gas. Or it might say, you know, what process is occurring at point B. So you go, oh, we're going from solid to liquid. So that would be, you know, so that would be freezing and melting. You know, it might say, or it might give you what phases might be present at 200 degrees. So you know, well, it's somewhere over here. And so you might have a liquid, you might have a gas. Those kind of things. So if you get a point on the phase diagram, kind of what phase would you be at, what process might be occurring, things like that. Phase diagrams are not difficult, they're just a little weird when you first look at them. But once you look at a phase diagram for several different substances, you go, oh, well, the concept is always the same.